All right. Okay, so thermal expansion. Okay. So before this, we have learned about okay. Where is it? Let me see. Chapter 8. Heat. Yeah. Yeah. This should be the one. Yeah. So write a new page. So before this, we have learned about heat conduction. We have learned about heat conduction. We also learned about some material is a good conductor, some material is a bad conductor. So right now we learn. Now we're going to start with thermal expansion. That means some material will expand faster, some material will expand slower. Okay, that's thermal expansion. Okay, so yeah, so let me just write something over here. So 8.4 thermal expansion. Okay, thermal expansion. Okay, so going to learn about the material expand. Just hold on a second. So many disturbance. Yeah. Okay. Yeah. So sorry. Okay. So sorry. For waiting. Yeah, because calls keep coming in. Yeah, everything. So thermal expansion is we're going to learn about when like metal rod, you heat up the metal rod. The metal rod will expand. Yeah. Based on what formula? Okay, the formula is this formula lah. Delta L equal to alpha L naught delta T. You see that? Okay, I like to write over here. Yeah. So delta L equal to alpha L naught delta T. Delta L equal to alpha L naught delta T. So what is delta L? What is delta L? Delta L is change of length lah. That means expansion. Change of length. When you heat up the, I have a metal rod. For example, I have a metal rod, and then I heat it up. Yeah, I heat it up. So what happened is the metal rod will expand, right or not, class? The metal rod will expand like that. So we have, this is the original length. L naught is the original length, and then this one is the delta L, change of length. Yeah, it expand. Yeah, when you heat up the object. Okay, expand. So delta L is the change of length or expansion. I can say it is the expansion lah. Yeah, expansion. But not just heat it up. Sometimes, if temperature increase, of course it expand. So it's either expansion or contraction. So actually is got two situation lah. If you heat it up, it expand. But if you reduce the heat, reduce the temperature, you put it in under cold temperature, then it will undergo contraction. Correct or not? The metal rod will get longer if you heat it up, but it will become shorter if you put it in cold temperature. Correct? It can become longer or become shorter, can expand or contract. Okay, based on the change of temperature. Okay, so that's it. Now, how about alpha? What is alpha? Yeah. So alpha is like we have learned about, we have learned about stress and strain. We have learned about. Am I recording? Let me check. Yeah, I'm still recording. That's good. Yeah, that's good. I have to check everything. Yeah, just to make sure. Okay. I did try and I didn't record the session, yeah, in the end. So it's okay. Stress and strain. You learn about stress and strain. You learn about, for stress and strain. You learn about Young modulus, right? Not Young modulus or K or force constant. Young modulus or force constant is the rigidity. Is rigidity of material. What is mean by rigidity of material? Kekerasan, kekerasan material. When you want to, you want to bend it, the object, you feel the material is very tough, very keras, yeah. That's stress and strain. So different material has different rigidity. Different material has different rigidity. So Young modulus and K all depend on type of material. And then under the next topic about thermal conduction. Thermal conduction. What do we learn? We learn about K also, which is the thermal conductivity. Thermal conductivity. Yeah, thermal. Okay, I need to wait a second. Yeah, it's about thermal conductivity of material. Thermal conductivity of material. So different type of material has different type of material can conduct heat with different ability. Some if that means if high K means a good conductor. Good conductor. Is a good conductor of heat. And then we also have small, small value of K means is a bad conductor, bad conductor of heat. So in thermal conduction, we also learn K depend on type of material. In stress and strain, we learn that Young modulus and force constant depend on type of material also. Now we are learning about thermal expansion. We're learning about thermal expansion. Thermal expansion also, thermal expansion has symbol alpha, have beta, gamma. All these also depend on type of material. Understand? They all also depend on type of material. They are called. They also depend on type of material. That means what are all these quantity? They are ability to expand. Some material expand faster, some material expand slower. So what I can say is if all these alpha or beta or gamma, okay, they have high value, D means they expand very fast. They expand fast lah, expand fast. If you have a small value of alpha or beta or gamma, means expand slow. That's it lah. It means that this type of material, if they have high value of alpha or beta or gamma, if the type of material has high value of alpha, beta, gamma, means they expand fast. Expand very fast lah. Become longer very fast. But if they have small value of alpha or beta or gamma, means they expand very slow. Understand? So why we have alpha, beta, gamma? Because we have for length we use alpha. For area expansion we use beta. For volume expansion we use gamma. Understand? Alpha, beta, gamma, length, area, volume. So you see, all these quantity, Young modulus, force constant, thermal conductivity, and then all these alpha, beta, gamma, they are actually called what? They are actually called coefficient. I just write again. This one is all coefficient of thermal expansion. The coefficient of thermal expansion. So all these quantity, they all depend on type of material. They all depend on type of material. Like what I say, you have Young modulus of steel, you have force constant of copper, you have thermal conductivity of steel, thermal conductivity of glass, and then you have alpha for what? Alpha for iron. I have a gamma for petrol. Depend on type of material, gamma of maybe oil. All type of material. So all different material has different value of all this quantity. Understand? Okay. Now, again, what is the name of alpha? Okay, look at the notes. Alpha is coefficient of linear expansion. As I said, this is for now we are focusing only on length. On length. Length. So this is the under what? Linear expansion. Linear expansion. Linear expansion. So linear expansion means length. Length. Length is for expansion of length. Okay. Later we have area and volume. But that one later. Area and volume. Okay. So alpha is what we call coefficient of linear expansion, and they depend on type of material. Understand? Type of material. Okay. So what is the what is L naught? L naught is the original length. L naught is the original length. L naught is the original length. And what is the delta T? Delta T is change, or change means increase or decrease in temperature. Increase or decrease in temperature. Change, change or in temperature lah. Increase or decrease in temperature. Okay, what's the unit, class? What's the unit? Change of length is meter. And then alpha, we don't know the unit, isn't it? Never mind, we don't know the unit. Never mind. Later we use this formula to find out what's the unit for alpha. Okay. For length is change of length is meter. Initial length is also under meter. And change of temperature. Remember I talked about change of temperature. Change of temperature can be either degrees Celsius or Kelvin. Remember, I mentioned about this change temperature. If temperature alone, the unit, the SI unit, you must put Kelvin lah. But change of temperature, you can just put either degrees Celsius or Kelvin. Understand? Because why? Because the increase in 1 degree Celsius is the same as increase in 1 Kelvin. I explained this before. So if the question give you the temperature in degrees Celsius and this formula need to use delta T, change of temperature, you no need to change to Kelvin. You can just stick with degrees Celsius. Understand? Just stick with degrees Celsius. But if the equation just use one temperature point, not the change of temperature, like for example Charles law and pressure law, that one you must change to Kelvin. For this equation where you use change of temperature, you can use either degrees Celsius or Kelvin. Understand? Okay, so now we can find the unit for alpha. This is for your UPS. Normally ask what's the unit for alpha, then you need to find it out. So how to find the unit of alpha? Well, because some question, subjective question also, maybe he asks you to determine the value of alpha. So your final answer must have the unit. If your final answer don't have the unit of alpha, then you lost mark, because answer must with unit. Okay, so you don't know the unit of alpha, you can use the formula to find out. We know the unit of the rest of quantity, so that's not a problem for us to find the unit for alpha. Okay, let's find it out. So delta L equal to alpha L naught delta T. So alpha is actually alpha is actually delta L over L naught delta T. Correct not, class? Yeah, go to the other side. So we have this one in meter, the L naught also meter. Change of temperature can be either degrees Celsius or Kelvin. So you see, class, cancel the meter. So what is the unit for alpha? What's the unit for alpha? The unit for alpha is either per degree Celsius or per Kelvin. That's the unit. Alpha unit is per degree Celsius or per Kelvin. So sometimes the answer you can see it give you in per degree Celsius, or sometimes the question will give you the answer in per Kelvin. Both accepted. Why? Because change of temperature can be either, because it's all because of change of temperature. Change of temperature can be either degree Celsius or Kelvin. Understand? That's why alpha also can be either per degree Celsius or per Kelvin. Itu sajalah. Understand? So that's the unit for alpha, coefficient of linear expansion. Okay, what else? What else did I need? Okay, good. I will explain a bit more about alpha later. Yeah, about what's the meaning of alpha actually. I will explain more based on this formula. Okay, not now. Now I want to explain what is actually this. What is it actually mean by this formula? Delta L equal to alpha L naught delta T. What is mean by this? Okay, so let me explain. Wait. So okay. All right. Let me. I selected. Okay, that's good. Okay, so I rewrite the formula over here. Delta L equal to alpha L naught delta T. This formula is for formula for thermal expansion. So apalah? What is mean by this formula? So it means that the change of length or increase of length when a metal rod is under a fire. Let me copy this. Okay, let me. Okay, just why the cursor? Okay. Now, when this metal rod is under fire, heat it up. Okay, so how much is the change of length? The question is how much is the change of length? How to determine the amount of change of length? Or I can say what factor contributes to the change of length? What factor? The change of length based on what factor? This is the answer. It based on 3 factors. It based on what type of material it is heated up, what type of material. It based on the original length. It based on how much increase in the temperature. Understand? So it means that it based on material. Firstly, it based on material. If the material has, it based on material. It based on material. It based on original length. It based on change of temperature. Understand? So that means what does it mean? I should put it in a green color first. So it based on material. So if the material has the ability to expand very fast, if the material has high alpha value, mean it expand the change of length also very high. Understand? If the material can expand very fast, means it has high alpha value. So the change of length also a lot. The change of length also a lot when heated up. Understand? Understood? Okay. And then what other factor influence the change of length? It depends on the original length. Which one will expand faster if you heat up 1 meter rod compared to you heat up a 100 meter rod? I have two rod. One rod is only 1 meter. This 1 meter. Another rod another rod is 100 meter. 100 meter. Both you heat up to same temperature. Yeah, you both also you heat it up. Yeah, both also heat it up. Which one expand much? Which one will expand much more? Which one will expand much more? Of course, the one with longer initial length, L naught, isn't it? This one will of course will expand much more compared to the short one. This one will expand much more. The delta L, of course, much more. This one expand maybe only a little bit compared to the isn't it, class? The longer one, of course, expand much more compared to the short one. Yeah lah, this 1 meter expand maybe okay lah. If 1 meter expand 1 cm, if 1 meter can expand 1 cm, what about 100 meter? 100 meter, of course, expand 100 cm lah. Correct or not? It's proportional mah, proportional. Like a railway station, kan? The railway. Sometimes, the railway, jalan kereta api, they have to build some gap, they have to build the gaps. Cannot be, because railway is very long, very long. L naught, very long L naught. Understand? Very long L naught. So the delta L also a lot. Yeah, it's more than 100 meter. For actually railway, what is rail? How to spell railway? Railway, kereta api punya. Is 100 kilometer also have, kan? From through Sabah got railway or not? Okay, how many kilometer? Kilometer, so the initial length, very long initial length. Of course, very large delta L, kilometer. Then expand how much the delta L. So that's why for railway they have to build this gap. If not, the expansion is very ketara, yeah. If no gap like that, then what happened to the railway? It become like Bangkok lah, Bangkok. You know that? Because it's so long, so expand also a lot. So they can Bangkok. Or because of what? Or because of delta L. Understand? When under a hot sun, the hot sun, understand? Okay. So delta L. So initial length long means change of length also a lot. Okay, change of temperature, of course lah. Change of temperature. That means if you heat up, for example, class, you heat up from 20 degrees Celsius, heat up to 21 degrees Celsius. How much is the change in length you can expect? How much is the change of length you can expect? You just increase 1 degree Celsius. How much of change of length? If you heat up to, let's say, 20 degrees Celsius, you heat up, you kasih bakar, you heat up to 2000 degrees Celsius. What is the change of length? Of course, very high lah kan? Because the change of temperature is so high. Correct or not? What can you expect if you just heat up 1 degree Celsius? Very little. But if heat up to a lot of change of temperature, yeah, heat up very high change of temperature, very high increase of temperature, of course you get more change of length, increase of length. Understand? So it's very simple based on these three factors: material, the initial length, and the change of temperature. That all will affect the increase of length. Understand? That's the concept lah. Okay. So continue. Okay, continue. So I continue with this delta L equal to alpha L naught delta T. Okay, so this change of length affected by these three factor. Now, final length. Final length, that means okay lah, I copy this one. Okay, copy and then paste it over here. Come on. Wait, hold on a second. Very hard. Okay, class. So what is the final length, class? Final length. So final length is we can see from the diagram after the metal rod expand with delta L. So final length is L naught plus delta L. Correct or not, class? Final length is L naught plus change of length. So now you substitute the delta L with alpha L naught delta T. Okay, so and then we can further get the formula. L naught you factor out, then you got 1 plus alpha delta T. See that? So that's the, if you want to find the final length, that's the formula. L naught bracket 1 plus alpha delta T. Okay. If you will just want to find the change of length, then just alpha L naught delta T. Okay. So what else I need to, okay, one more thing. This is the linear expansion, class. Linear expansion. Okay. We also have area expansion. Area expansion, which is what about area expansion, class? Let me write it out. Then we have area expansion. Area expansion. Area expansion just change the symbol. Last time is delta L equal to alpha L naught delta T. So if area expansion, that means what? That means something like this lah. Yeah. If I have an area, let's say a copper area, I heat it up. So this copper area also will expand. Yeah, copper plate lah. I can say copper plate. It will expand also, right? It expand. It become bigger area, bigger area like that. Yeah. So I can say that this is the original area, and then after heat up, you got a final area like that. Bigger area. Understand, class? Or maybe it's originally it's just a circle, circle. Now after heat up, it become bigger. After heated up, like that. Okay, so we also have formula for area expansion, and the formula is the same as the linear expansion. What's the formula? Can you guess, class? Can you guess? Everybody, good guess. So change of length become change of area, and then alpha become beta, and then initial length become initial area, and then change of temperature. That's it. That's it. Okay. And then also you want to find the final area, just take initial area plus change of area, and then finally we also get the same formula, A naught 1 plus beta delta T. I just translate from this one become this one. Understand? How about volume, class? Volume expansion. Volume expansion. We also have volume expansion. So area expansion. This formula. If volume, how? Volume means how to draw a volume. A cube lah. A cube. A copper cube. I got heated up. heat it up, now become bigger. Once it heat it up, it also become bigger. Bigger. So how to draw? Yeah, just draw a bigger cube lah. Just draw a bigger cube. Yeah, that's it. Yeah, that's it. Yeah. Okay. So once it heated up, it become bigger, right? So okay, class. So the formula is delta V equal to if beta become gamma, and then volume initial delta T. If volume final, just take the volume initial plus delta V, change of volume, and then just translate from this one. Volume final is volume initial 1 plus gamma delta T. Volume initial 1 plus gamma delta T. That's it, class. That's it. You understand? Okay, class. Now, I have, I should write it like this over here. Okay, all these are, this is the for linear expansion. Okay, my words are terrible. Okay, sorry. Now, just put it over here, class. Yeah. Wait. Let me adjust it. Yeah, that's it. Yeah. Okay, class. So you have linear, you have area, you have volume. Now, area, the beta. Let's say I have alpha for copper already. Okay, I have alpha for copper value, let's say 20 lah. 20. What's the unit for alpha again, class? Per degree Celsius, or you can write is 20 per Kelvin. Understand, class? Understand? So now if I have alpha copper value, now if let's say I want to find the change of area, I need the beta. I need the beta value. What's the beta for copper? What's the beta for copper? Beta for copper will be 2 alpha. 2 alpha copper. 2 alpha only. That means which is 40. The unit also the same. Unit of beta is the same as unit of alpha. Yeah, beta has a unit of same as alpha because alpha is what unit? Per degree Celsius or per Kelvin, right? So same goes to beta. Beta also per degree Celsius or per Kelvin. So beta will be 40 per degree Celsius or per Kelvin. Understand? So for beta, for what? For beta lah. For beta. Now, if I want to find gamma value, I want to find. Let's say I need to work out the change of volume. So I need the gamma of copper. Let's say this is the copper cube. Copper cube. So I need the gamma value. So how many times alpha? If gamma for copper, it will be 3 times alpha for copper. 3 times. If beta for area is 2 times. If volume is 3 times. That's it. That's so simple. Which is how many? 3 times 20, which is 60 per degree Celsius, or can write as per Kelvin. Understand? Understand, class? Okay. Good. Thank you. So, yeah. So, if you have a copper rod, if you have a copper rod, then you can find the change of length for copper rod, delta L, using the alpha value. If you have a copper plate, you use the beta copper, which is 2 times the alpha copper. If you want to find the copper cube, if you have a copper cube, you want to find the change of volume when heat up, then you need the gamma. The gamma is 3 times the alpha for this copper material. 3 times. 2 times, 3 times. Alpha, beta, 2 times. Volume, 3 times. So easy. Okay. What else? Yeah, I need to explain what is actually mean by this. What is actually mean by alpha value? Yeah, alpha value is if you rearrange the formula, L naught go below, delta T also go below. So what is actually mean by alpha? If you look at these notes, he say that alpha is the coefficient of linear expansion, is defined as fractional increase in length of a solid per unit increase in temperature. Do you understand, class? This one? These terms, this word? Do you understand? Fractional increase in length? Let me write it out over here. Let me just put it over here. Yeah? Put it over here. Why it just not listening to me? Yeah, the cursor, where is the cursor? I cannot see the cursor. Yeah. Yeah. That's it. Okay. So yeah. So alpha is why so small the letter? Sorry, you have to be patient with me. Yeah, that's better. Okay, so now alpha is called fractional increase in length of solid per unit rise in temperature. Do you understand? Do you understand this statement? What's the formula again? Alpha is what's the formula again we derive? Alpha is why is it? Okay. See, alpha is delta L over L naught delta T. We got that right? Okay, I want to rewrite over here. Alpha is delta L over L naught delta T. You understand this one? You understand this one? Fractional increase in length. You understand? That means this one actually is L. Okay, I rearrange the formula. L naught go above. L naught go above over L naught. Actually is like this. So the top here is called the fractional change. You see the top here. This is actually a fraction. You see the words here. Fractional increase in length per rise in temperature. So the top one is here. This is a fraction. The top one is a fractional increase in length over increase in temperature. Fractional increase in length. You understand? Like this lah, yeah. Maybe I should give one example. Now, because of increase in the beras, yeah, harga beras sudah naik. So now a plate of nasi lemak has increased 50 cent. Okay, like this, like this. So last time our one plate of nasi lemak ayam, okay, is nasi lemak ayam. The price of one plate of nasi lemak is 7 ringgit. Now suddenly, because of the rice, the rice price has increased. So the person, the seller want to increase the price of nasi lemak 7 ringgit to increase 50 cent. Increase 50 cent. 50 cent. So how much is the final price right now? RM 7 ringgit 50 cent. When the price has gone up, it never go down. Yeah, any consumer price gone up, it never go down again. That's the reality of life. Yeah. So, how much fractional increase in the price of one plate of nasi lemak? How much? This is the nasi lemak ayam price. One 7 ringgit. But now because the rice, you know, beras, harga beras sudah naik, tahu tak? Harga beras sudah naik. Itu penjual pun ambil kesempatan lah. Ambil kesempatan, dia kasih naik setiap nasi lemak ayam ni 50 sen. So sekarang harganya 7 ringgit 50 sen. So what is the fractional increase in the price of a plate of nasi lemak? So the fractional increase in the nasi lemak is the change of I just say change of that means the change of length. I treat it as change of the price lah over initial price. The change of this is like the change of length, and this is like the initial price. Yeah, initial length and the change of length. So how much? 0.5 and then this one is 7 ringgit, correct or not? Original price is 7 ringgit and the increase of price is 50 cent. So can you calculate for me what is the value for this one? Can you calculate? Wait, let me, can you calculate for me? What do you get for this one? What do you get? 0.5 divided by 7. 0.07. Right or not? 0.07. This is the fractional increase. Fractional increase in length. This is the fractional increase in length. Understand? Fractional increase in, not the length lah, the price of nasi lemak, fractional increase. If let's say I multiply by 100%, if I multiply by 100%, so what do I get, class? I get 7% increase in the price of nasi lemak. You know that? Now because they increase 50 cent, that means every plate of nasi lemak I eat now has a 7% increase in price. Okay? So that is mean by fractional increase in length. Understand? So let's say that means per unit increase in temperature, per unit rise in temperature. So that, like for example, let's say I have alpha for copper is actually should not be 20. It's maybe 0.02 per degree Celsius. So what does it mean by this value, class? What does it mean by this value? This value, it means there is a 0.02 increase. There's a 0.02 fractional increase in length per increase of 1 degree Celsius. That means it has 2% increase in length of copper rod when you heat up, you heat it up by 1 degree Celsius. Understand or not? Understand? If you understand, give you a thumbs up. That means if, let's say, if I heat it up with 2 degrees Celsius, what do you think? How many percent increase in length? How many percent increase in length? 0.04% increase. No, actually it's 4% increase in length. 4% increase in length of copper rod when you heat up by 2 degrees Celsius. That is what I mean by 0.02. You heat up with the more you heat up, the more the change of temperature, the more the change of length. Correct or not? You heat up by 3 degrees Celsius, you got 6% increase in length. 6%. This is fraction lah. If dalam bentuk perpuluhan, dia adalah dalam percentage, dalam fraction, pecahan, fraction. Okay. Kalau you heat up by 3 degrees Celsius, then it got 6% increase in length. Macam tu lah. 6% increase. That is what it mean by alpha is the fractional increase in length per unit rise in temperature. So alpha, what is alpha again? So alpha depends, again what I want to say is alpha is the, ini UPS tau, UPS. Saya susah-susah nak ajar ni, all UPS, all because of UPS. Alpha, beta, gamma is all depend on type of material. Type of material. So you have alpha for copper, maybe alpha for copper maybe 0.02. But you have other material like alpha for glass. Is copper expand faster than glass. Copper expand faster than glass. So glass maybe is only 0.012. Okay. So that means this one, like copper, it can expand 2% per rise of 1 degree Celsius. But this one, glass, only expand 1.2% per rise of 1 degree Celsius. You understand, class? Different material has different ability. Different material expand differently when heat up. Some expand faster, like this one expand, like the copper expand faster, the glass expand slower. Glass expand only 1.2%. Copper can expand 2%. Much faster lah, copper. Maybe for other material like brass is 0.04, means expand 4% for each degree of Celsius. So brass expand much faster. So like that lah. So alpha is for material. Okay, class, if you understand, give a thumbs up. Okay, I think that's all for today lah. Yeah, that's all for today. We will continue some other time. Yeah, so sorry for extra for 3 minutes. Okay, so later this video I will upload to YouTube. Yeah, hopefully if you don't understand, you can rewatch lah. Yeah, and the later class I will continue from here. Some more thing I want to talk about liquid later on. Okay, so thank you all for your time, and see you in the next class. Bye.